If the morning was about interdisciplinarity in detail and in practice and in theory, and the afternoon we leave the, at least I believe we will leave the theme of interdisciplinarity and instead talk about risk-taking in research or frontier-breaking research. I'd just like to say a few words why we chose this theme for the afternoon. The Pufendorf Institute has certainly renewed the landscape of Institute for Advanced Studies, and one of the profiles that we rely heavily on is the interdisciplinarity. And that has, can we say, with some evidence, been very successful. And those of you who were with us in the morning, hello Ingrid, please come in. We have just about started. That we almost had witnesses about the greatness of interdisciplinarity and the Institute. So it could be expected that we would have followed along the same track. But today, interdisciplinarity and working cross-border between disciplines is very well embraced, actually. We still say that people do not want to work together and across disciplines, but actually evidence proves differently concerning this. And the interdisciplinarity is more or less on everybody's lips. And sometimes it even seems to be the standard solution for all kinds of problems. Not to say a religious belief that if we only work together, everything will be solved. So we don't have to make any more missionary work there. That's my belief. And we already are the EAS for interdisciplinarity. So we thought, well, if we are to think something, to take up a discussion that is not talked so much about, what would that be? What would be a mission for the next 10 years, if we have any? So I did a simple Google search on the word interdisciplinary and on the keyword risk-taking research or frontier-breaking research or breakthrough research. And guess, and only in the Swedish-speaking Google, I got 268,000 hits for only the word interdisciplinary. 268,000 hits. If I search for risk research, or which might be a quite Swedish concept, it's more breakthrough research or frontier-breaking research. That is the term used in English. In the Swedish search, I did almost get nothing at all. I got information about fire safety, all kinds of risks, but nothing about to foster research that takes a risk. In more or less, and nothing in Google Scholar either, on any kind of frontier breaking or groundbreaking or breakthrough or risk research. Well, of course, the same brands as fire safety came up. The only thing, both in Google Scholar and the more public Google, that referred to frontier-breaking or groundbreaking research was a report from the Academy of Science, written by Gunnar Ökvist and Mattsson in 2012. So the only loops I got referred back to that publication from 2012, if you remember, Ökvist and Benner, about fostering breakthrough research. And they had a suggestion of how Sweden should foster more breakthrough research. And then it seems that that discussion more or less died or went silent. I know that the Research Council made some excellence calls, but there's not a vivid, sharp discussion on this topic. So that's why we are doing it here today, because it has to be revitalized. And in order to have that discussion, we have gathered four guests with interesting experiences and backgrounds that I believe will enhance this discussion together with us. And first of all, I would like to invite Pauline Mattsson, who is rather recently recruited to Lund University and the Department of Business Administration at the, what do they call themselves? EHL, what do they call them? The Center for Economics in English? Faculty of Economics, of course. So please, Pauline, the floor is yours. So, and you can also read on the back side of the program. You can read the very crammed CVs that we have made for them, okay. All of our speakers.
Okay, then there's no need for me to present myself.
Or you can do. Not everybody has the program in hand.
Okay. Yes, my name is Pauline Mattsson. I got here like 1.5 years ago, and I was formerly at Karolinska Institute. So that's why I also, most of this research I will present here, I carried out at Karolinska and some other places in the world. And I also want to say that I did this research together with Katarina Nordqvist, who used to be at the Nobel Museum. She's not there anymore. So what I'm going to present today is, I'm very aware that it's a very limited group, and what I present here might not be applicable for all researchers, so we have to bear that in mind. But still, I think there is some learning, and also from what they say and from their kind of experiences. So, I mean, we were interested in breakthrough research, and then we thought, I mean, how do we actually define this? So what is a good sample to look at? And I think most of us would agree that the Nobel Prize is kind of associated with breakthrough research. So let's first start with going back in time and why we actually have the Nobel Prize and the will of Alfred Nobel himself. So what he actually says in the will is that the ones that have conferred the greatest benefit to mankind and have made the most important discovery within the domain of physiology and medicine. So what I'm focusing on today is the prize in physiology and medicine. They should be given the prize. But we talk about breakthroughs and what is actually a breakthrough. If we just look at the Nobel Prize, we have plenty of different type of breakthroughs, and I am not going to say that this list is exhaustive. I mean, we have breakthroughs in all other kinds of fields. But just to give some examples, here we have an example of a breakthrough or a prize in theory. And this is actually the notes from Niels Jerne, who got the prize in '84, from his Nobel lecture at Karolinska. And he got the prize for theories concerning the specificity in development and control of the immune system and the discovery of the principle for production of monoclonal antibodies. So what he presented was a theoretical outline how he thought this process would work. Another type of breakthrough discovery is the discovery by Andrew Fire and Craig Mello in 2006. They got the prize for their discovery of RNAi interference. So this we could name like more of a phenomenon, what they actually came up with. Another example was awarded to Robert Edwards in 2010. So he got the prize for a method. This is the picture from the newspaper, the Daily Mail, the announcement that the first child, Louise, has been born using IVF. Another example, a breakthrough in a technique or an instrument. So this is an example from the Nobel Prize in 2003. Paul Lauterberg and Peter Mansfield, they got the prize for their discovery concerning MRI, magnetic resonance imaging. Another type, and my fifth example, is the discovery of a virus. This is an illustration of the Nobel Prize in 2008 that was awarded to Françoise Barré-Sinoussi and Luc Montagnier. And they got the prize for the discovery of the HIV, so the human immunodeficient virus. So these are only 5 examples of type of breakthroughs that you could have. But of course, I mean, you can have breakthroughs in other fields and in other kind of domains as well. So before I go more into the project and present some of the results, I just want to give some background what we actually did in this project. I also want to say that since we have Vetenskapsrådet here, we actually got funded by VR, so thanks for that. So the focus was on the Nobel Prize in Physiology and Medicine. And the main reason for that is actually that both of us have a life science background. So it was very helpful to dig into the articles and at least understand a bit when we also went out to talk to the laureates. So we covered the period 1978 to 2013. So we included all the prizes and all the people behind these discoveries. Then we went out and we did in-depth interviews with 34 laureates, and mostly in their offices, but also sometimes we visited them back home. We also gathered a lot of secondary data, so like all publications, all patents. We also tried to establish if they had any kind of links with industry, so to say if there were any startup or spin-offs from their research, consultancy activities, and board involvements. And the reason for this is that we were also interested in what did actually these kind of breakthrough discoveries lead to and their kind of translation process from a discovery and out to some kind of a use. So, and here I see that the formatting of a Mac is kind of changing my PC presentation, but as long as it's clear. So what we first did was to try to understand why are they actually doing this? So why did they go into this project? So what was kind of the motivation or the major drivers for carrying out their research? And here I'm just showing like the most common explanations or drivers. So they were driven by curiosity and to answer a specific research question. And these research questions could either be like a fundamental character to understand a specific process, or it could also be, since we're in the medical field, more applied, so especially the ones with a more clinical background, something that they had found in the clinics, so to try to understand a specific disease or something like this. And then another thing that would, maybe these ones are not that surprising, but the third one I think is a bit more surprising, and that is that many of them actually said they wanted to go into this field or this specific question because there were very few researchers doing this. So motivation that no one had actually done this, and there was like a niche field. And this is also visible if you look at what they did later on after the discovery. So when they had been able to answer this question, they jumped into another field or into another question, so completely switching from one area to another, because that was like the driving factor. So I think this quote is quite interesting. So this is from Albert Gilman, who got the prize in '94 for the G protein. So I love basic research for its own sake and to understand fundamental knowledge. And that is what I've done all my life. And yes, it has to be brought to fruition and products, he said. So another thing what we did is that we wanted to look at the co-publication network. So we identified a matching group. Of course, it's impossible to do. I mean, this is human, so it's impossible to find a perfect control group. But these are very, the non-laureates, they are still involved in the Academy of Science and published well, and also we also looked at the H index and so on and so on. So what we found here is that if you look at the network of the laureates, that it was much kind of tighter, while the comparative or the control network were much more like clustered into different type of clusters. And then we did a number of different kind of statistical analysis. And so what we find is that the laureates are tighter, but they are much better at bridging out and getting access to different type of clusters. And this could then be like an indication that they are better at, now we're coming back to this interdisciplinarity, but somehow maybe it's also connected. So to draw on ideas, theories, techniques in different, in other type of fields. And then, of course, always coming back to the same question. So we asked about their funding. And many of them said that they actually didn't get funding for their initial idea. So they didn't get funding to actually support the breakthrough. And what they then did was that they applied for something else, so to say more safe, and then they used that type of funding for their discovery. And then much further into the process, they started to be able to get funding. So I like the second one here. The first grant to fund this work was trashed by NIH. And they also talk about that they were fighting with the funding agency to try to convince them that this was actually something. Another very important thing that, I mean, I think we all know, but that it really takes time. And this is something they also witnessed, that was actually something good, that they were able to stay in this kind of small subfield by themselves. So for 8-10 years after the discovery, most of the people didn't believe in the results, and they went out to present the results and were really questioned. So it really took time before they were able to establish their results. And then, since we were also interested in what actually have happened to these breakthroughs, we tried to draw like a timeline. So what we see here is like the key publication when the first one came out. And we looked at the patents, the first patents that came out from this discovery, and it took 11 years on average. it's important here to say that these are patents that are relevant, somehow draw on the research that they got the prize for. The first co-publication with industry was published on average 13 years after. And then the ones that had startups, that's even longer. So that's like 17 years after the key publications. And then we see, they got the Nobel Prize 21 years on average after the first key publication. So, I think this is a question that we're always trying to ask ourselves, and Web of Science have tried to do predictions, so when can we predict the breakthrough and so on. And of course it's not easy. And what we did is that we looked at the age index of the different laureates, and as you can see here, it differs from like having 8 until the one that had the highest, I think, was like 140 or something. So it's really not, several of them didn't really have a high index, like a star age index, as we call it. And then we also looked at the highest citation, and also here there's absolutely no kind of normal distribution or average here neither. So one interesting thing that I don't show in this graph is that 50% of the laureates, their highest cited paper was not the papers that they got the prize for. So, and then another thing that is quite interesting is that not all of them have published their results in Science and Nature. This is a letter to the editor for the IVF prize. So there's only a small letter saying that we wish to report that our first patient, Louise, was born today. So, and then I don't know if you can market research, but I'm very interested in these questions, and we're just starting off a project now where we are looking at the role of scientific training, and especially the PhD and postdoc period, to try to understand if there are any contextual factors and also that are important to actually foster what they do later on. So are there any factors or type of teaching that you can see, or training, that then facilitate or encourage researchers to become risk takers and actually carry out breakthrough science? So this we're going to look at all PhDs in life science in Sweden, and then follow their career track and actually also talk or send out questionnaire to the PhDs and also to the supervisors to see if there are anything there that are important for fostering what they do later on in their career. Okay, thanks a lot.
Thank you very much, Pauline. You can just stay on for a second. I think we can work it this way, that if you like to ask more straight questions or clarifications, you can do that right away. Whereas if you like to raise a bigger issue or questioning rather than a question, if you could please wait with that to the end discussion. So if there is, yes.
Very interesting presentation here. I wonder, at the time of breakthrough, was it really notified as a breakthrough at that time or in retrospect?
Yeah, so what they say is that they were these are very self-confident people, very self-confident people. And what they say is that, they were pretty sure, they were very sure about the impact. They were not really sure about maybe the impact they were going to have, but that this was something really specific and a breakthrough. And since also many of them were quite young, they were very kind of persistent in their results. So among themselves, yes, I would say that they were aware. But then in the bigger community, many of them witnessed that they were sitting there at their first conferences, like presenting the results and getting really questioned by the rest of the scientific community. One thing that is important to mention is that many of these laureates actually have been already at an early stage, or at the PhD postdoc stage, located at very high-profile environments with other great scientists. So, yeah.
Okay, you told us a lot of figures here about how many years it took after the breakthrough, etc., how many years it take to get the Nobel Prize. But how large are the deviations? Is it similar between the different laureates, or does it deviate a lot?
So you mean where they are in their career?
But you have averages.
Yeah.
Yeah.
Yeah, so what I said is like it's not a normal distribution. And what we also have is that we see many couples where you have a PhD or a postdoc and a professor. So that's not included in the picture. But on average, 44 of the laureates, they did their discoveries, 40 laureates did their discoveries as postdocs or associate professors.
I guess it's possible to figure out from that figure.
Yeah.
Yes.
Hello. Yeah. So you show in the timeline some of the milestones after the discovery, like their startups and their. Is there any trend in how many of them are startups? How does this go?
Yeah. I mean, so we looked into how many that got a patent.
It's not me.
Yeah, someone that want to join the presentation. Yeah, so we looked into the percentage that actually had patents, and there was a really high numbers, almost 80%, 75%. I cannot remember exactly the figure that be taking a patent. And then when you look at the startups, that's also a really high number. And there is other studies that show that star scientists are more prone, and then you can discuss why, because I mean maybe they have a more of a star quality. It's easier for them to gather funding to start a startup. So you need to bear that in mind as well. But many of them actually did take place. But we have another study where we show that. I mean, we're talking about a specific group here, and they are not alone, of course. So here, for example, we see different kind of networks within their surrounding play extremely important role. For example, when it comes to patenting, their postdocs is the main driver where they actually go out and patent their results. Also, startups is also very much driven by former students and tech transfer offices after the Bayh-Dole. So they don't mind to share it, that their scientific breakthroughs come into use, but they want to stay in science and do what they are, I would say, best at. Yeah.
Thank you for an interesting presentation. Would you be able to take the risk to formulate a comprehensive short definition of a breakthrough? That's the first one. And the second one is much easier. Was the breakthrough acknowledged by the parent institution where those laureates had been trained?
Yeah, so the first one, I think it actually would be interesting to discuss that when we've also seen the other presentations, no? And then we can have, am I now escaping that question maybe? But maybe we can have a more of a general discussion about that, if that's okay for you. And the second one is that we also looked at the institutions, and I mean, you always see like Harvard coming up at on their main website saying that we are one of the universities that had most Nobel laureates. But if you actually go back and look at where they actually did their the research when they did the breakthrough. It's another picture. So it's another type of ranking. So then Harvard is not at all that high up. So a lot of laureates were at Harvard when they did, for example, their PhD, but then somewhere else. And then when they did the discovery, and then they're kind of getting recruited at the senior level back to Harvard. And it's also interesting to see that different institutions have had different kind of roles in time. I mean, for example, MRC in Cambridge have had, at one point, had a very important role with several laureates actually doing their breakthroughs.
Thank you very much. Did we applaud properly? I don't think we did.